All right, y'all. So, you know how they say third time's a charm? Well, this would be my fourth time trying to record this video because technology has not been my friend today. So what I'm basically going to be showing you is another method in which to solve equations. So if you understood solving equations using the traditional method and it wasn't an issue for you, then you probably can stick with solving equations using the traditional method. However, I want to give you another option in case you struggled with the traditional method just because maybe it was overwhelming and there were a lot of parts to it. So typically, I know you see that all these boxes that are drawn. Typically what you will see is you will see the equation written like this, and you will have to draw the boxes yourself. I went ahead and put the boxes in there for you so that you could type into this document. However, you will typically have to draw the boxes yourself if you choose to use this method. Again, when you have your formative on, I believe, Thursday, we're giving you that option as to if you want to use the traditional method or the box method to solve. So let's get started in the box method. So just like whenever we were solving traditionally, we really collected our variables on one side and our constants on another side. We're doing the exact same thing in the box method. However, the boxes are just kind of like a graphic organizer like you would use maybe in RELA, but we have a graphic organizer for math. So this kind of gives you a way to organize your stuff a little bit better because I feel like some of you get lost in the steps and it's super overwhelming. This helps organize it for you. So if I have variables on one side and constants on the other side, I'm going to go and I'm going to collect my variables on one side. So I have this 6x that I'm just going to drop down. I'm going to drop that 6x down. And then I have this 8x over here that I'm wanting to bring to the opposite side of my equation. Notice it is on the right-hand side and I'm wanting to bring it to the opposite side. To be able to bring it to the opposite side is going to affect it a little bit, right? I can't just take something to the other side of an equal sign and nothing happened to it. So if I'm taking it to the opposite side of the equal sign, I have to take the opposite of that value. So if I have an 8x, the opposite of that value would be a negative 8x. And then I have my constant. So I have this negative 13 that I'm going to drop down. And then I have this 7 that I'm bringing to the opposite side. So if I'm bringing the 7 to the opposite side, I've got to take the opposite of it, giving me a negative 7. So my next step then is to combine my like terms on each side. So I have 6x plus a negative 8x, which gives me a negative 2x. I have negative 7 plus a negative 13, which gives me a negative 20. So now I just have one of those easy peasy 6th grade equations that we've been talking about. A negative 2x is equal to a negative 20. So if I'm doing a negative 2 times x, my inverse is going to be to divide by negative 2. So those cancel and I get x is equal to 10. Now, just like we've been doing, you can, to check your answers, you can still check your answer doing this. So anywhere I have an x, I'm rewriting my equation. Anywhere I have an x though, I'm putting parentheses. And I'm going to substitute in what I got for x, which was 10. So I basically have 6 times 10 plus 7, which gives me 67. I have 8 times 10 minus 13, which gives me 67. Since both of those numbers equal each other, I know that for sure x is equal to 10. I've proved that answer. Now, I'm going to look at this next one here. So again, I have variables on one side and constants on the other. So I have an 8x that I'm just going to drop down because it's staying on the left-hand side. And then I have this negative 9x that I am bringing to the other side. So if I'm bringing a negative 9x to the opposite side, I've got to take the opposite of it. So the opposite of a negative 9x is a positive 9x. Then I'm going to take my 6 and drop it down, my constant, and I have a negative 32 that I'm bringing to the opposite side. So the opposite of a negative 32 would be a positive 32. I'm going to go and combine my like terms. 8x plus 9x is 17x. 32 plus 6 is 38. And I have a great one-step equation now. I'm going to divide by 17, divide by 17. Those cancel, and I get x is equal to. So you may have typed in 38 divided by 17 in your calculator, and it gave you this really crazy decimal. You can write it as 38 over 17, or you can make it a mixed number of 2 and 4/17, or, I know a third or, you may have gotten the decimal of 2.24 and it just continued on. Now, if you are going to check this, using this decimal estimation would not be the best route that you would want to choose. If you are going to check it, you would probably the best idea would be to use that 38 over 17 to check your work. I'm not going to check it with you, but that would be because this one's a little bit crazy. You typically won't see something with this crazy of a fraction. But you would use that fraction to help check your stuff. Now, let's look at one that's a little bit more different. So I'm going to have, or it looks a little different. It's not really that different. So I have variables on one side and constants on the other. So I have this negative 2x that I'm going to drop down. And then I have this negative 5x that I'm going to bring to the opposite side. So I'm going to take the opposite of it, which gives me 5x. Then I'm going to deal with my constants. So I have this 12 that I'm going to drop down. And when I'm looking over here, I don't have a constant to bring over. So I'm basically bringing 0 to the other side. So I'm going to use, now combine my like terms. A negative 2x plus 5x is 3x. 0 plus 12 is 12. And now I have a sweet and simple 6th grade equation. So I'm going to divide by 3. Divide by 3. Those cancel. X is equal to 4. So again, you could check this by doing negative 2 times 4 is equal to a negative 5 times 4 plus 12, which gives me on this side a negative 8. On this side, a negative 8. So I know my solution for sure is x equals 4. The last one that I'm going to show you is this problem here. So I'm kind of giving you one more just to give you a little bit more of exposure to it. If you have questions, you're definitely going to need to reach out to us and ask questions if you've got them. So I'm going to have variables on this side, constants on this one. So I have 8x that I'm just bringing down. I have this 6x that I'm bringing to the opposite side. So I'm going to take the opposite of it. So negative 6x. I have this negative 40 that I'm just dropping down. And then I have this 12 that I'm bringing to the opposite side. So I've got to take the opposite. So a negative 12. I'm now going to combine my like terms. 8x plus a negative 6x is 2x. Negative 12 plus negative 40 is a negative 52. And then I'm going to, easy 6th grade equation, divide by 2, divide by 2. Those cancel, and x is equal to a negative 26. Again, you could check it. You should be checking it. I'm not going to with you because you can check it on your own. If you have any questions, if you are one of Ms. Mansker's virtual students and you have questions about solving equations, I need you in my Zoom meeting today or on Thursday. Mr. Aguilar offers one on Thursday morning. I offer one on Wednesday afternoon at 2:20 and Thursday afternoon at 2:20. Check your WAG. If you are one of the face-to-face students and you are at home learning this today, you are not sure and you didn't get the traditional method either, you need to make sure that whenever you come into class on Thursday, you are asking questions to figure out what you need to figure out. You need to start advocating for yourself. So if y'all have any questions, make sure you reach out to us. Have a good day.